Hi everyone, welcome back. So in this video, I'm going to show you an analysis of a Sallen-Key Unity-Gain low-pass filter as that you guys can see here on the left. So the Sallen-Key configuration has two resistors, R1 and R2, and two capacitors, C1 and C2. All right, so and of course it has an op-amp. And as usual, when we're analyzing an op-amp with a negative feedback, there are two very important assumptions that we can make. Number one, as shown down here, there will be no currents going into both terminals. No current, that means 0 amps going into both terminals. That means there will be no current going into here, there will be no current going into there. And the second assumption is that the V1 and V2 terminals will track each other. So V2 will just equal to V1, and V1 will just equal to V2. So in this example here, we have a VO on this node, right? This large node here, right? You're going to have VO also on the non-inverting node, all right? So that's the application of those two assumptions. All right. So as usual, before we can write equations, we have to obviously define our currents and voltages. So the first one I'm going to do is this current here. That's a current flowing from right to left, from here through C1 and then coming down here. Now there's a node here that is not labeled. All right, so this is VI, this is VO, but this node here is not labeled. So I'm going to label that. I'm going to call that VX. All right, so I'm going to call it VX. Okay, and so now, so I have a current coming in there. I'm going to call that IF. All right, I'm going to call that IF. And then I'm going to define, this IF current comes in, and it's going to split between, going that way and also going this way. So the first one is going towards the left, right? I'm going to call that I1. All right, so I'm going to call it I1. So there's a current, IF come in, goes to this node and splits between I1 and the other one I'm going to call this I2, right? This current that's flowing, going out this way. Now, you should notice that the current that goes through R2 will completely come down through C2. The reason is because of the first assumption, because there will be no current going into the non-inverting terminal. So whatever current that goes through R2 will completely come down through C2. All right, so you're going to have a current that kind of flows like that. All right, it kind of flows like that, and I'm going to call that I2. All right, so that's going to be called I2. Okay, so there's going to be a current that flows from VX, if you like, this node VX, across R2, and then down C2 to ground. All right, because remember, there's no current going into the non-inverting terminal. All right, so now we should be able to write a couple of equations here. I think the first one that comes to mind is the one that relates IF with I1 and I2. That's just basic KCL. So KCL equation. All right, so that's IF is equal to I1 plus I2. All right, so that's the first equation. Okay, so I mean, obviously with KCL, it really matters which direction you define your arrows. All right, so in the ways I've defined here, then this is my KCL equation. All right, now let's have a look at other kinds of equations. So for example, if you look at this current IF here, let's have a look at IF first, right? So IF is a current that flows from VO to VX. So I can write an Ohm's law equation that relates IF, VO, VX, and C1. All right, so let's write that. So this is Ohm's law. I think I'll put it down because there's a couple of Ohm's law. Oh well, I'll just put it here. Ohm's law. All right, so we have a just talk about IF here, right? IF is going to be equal to I equals V over R. V is going to be V out minus Vx, all right, all divided by, well, it's not divided by C1, obviously. It's going to be the impedance of C1, which is 1 over SC1. All right? Okay, so that's going to be equal to VO minus Vx times, of course, SC1. All right? So that's our first equation for IF. Next, you can also have, again, using Ohm's law, I can define an Ohm's law equation for I1, right? Because I1 is a current that flows from Vx to Vi. So I can write I1 is equal to Vx to Vx minus Vi. Sorry, Vi. All right, and divided by R1. Okay, so that's done for I1. And I can write also finally for I2 in a similar way. All right, so I can write I2 in a similar way. Now, for I2, I have a choice. I could write in terms of, I think there's one more label I should put here. Since VO is on this node, so this node here is also VO. So I'm going to put that label over here, right? So that node here is also VO. This node here is also VO, all right? Okay. So I can write about I2. All right, so I'm going to write about I2 in terms of just to make it easier, in terms of just the C2 part. All right, because I can write I2 in several ways. I could just write I2 simply about going across R2, which means the equation would be Vx minus Vo divided by R2. Or I could write I2 as related to C2. Okay, I could write it in relation to C2. Then it will be like VO minus 0 divided by 1 over SC2. That will be equal to I2 as well. Or I could even write an even longer equation that connects all the way from Vx to ground here, right? So I could say Vx minus 0 divided by R2 plus 1 over SC2. So there's 3 different ways of writing it. And I'm going to choose the one that is simplest in the sense that, well, I'm going to use the one that has C2. All right. All right. So that's what I'm going to use. So my I2 now, I'm going to choose this equation. So I2 is equal to, now even if you choose the other equation, it's fine. You should end up with the same answer. All right. So I2 here is going to be equal to VO. So I'm taking this I2 only. That means the I2 that is going through C2. So it's going to be VO, because remember, because this is VO, therefore that is also VO. So therefore, the voltage across C2 is actually VO. All right. So it's going to be VO divided by 1 over SC2, i.e. ZC2, right? The impedance of C2. All right, which is also equal to simply VO times S times C2. All right. All right. So now I have a KCL equation, and for each one of those currents, I have its individual equations. Now there is something to resolve here. Well, there's a Vx here which needs to be resolved because without resolving Vx, we will have too many unknowns, right? Now, to resolve Vx, one of the things that we can look at is knowing the fact that if you look at the current, that is I2, that is, it actually flows through R2 and then completely to C2, meaning that R2 and C2 are actually in series, because the same current is flowing through both components. So these two are actually in series now. So they're in series, and then on one end you have a Vx, and then in between you have a VO. So you actually have a potential divider circuit. So here I've drawn a kind of extracted that part of the circuit where, so if I'll put it over here. All right. So yeah, so there's you have that Vx that's basically from here to all the way to ground, right? There you go, Vx from here to ground. And then you have the R2, right? I've just drawn it vertically up. And then you have C2, because the same current will then flow all the way from top to bottom, like so, right? So that's how I know it's actually in series, all right? And that current, of course, is I2, all right? So maybe I'll just put there to remind you guys what current that is. That's just I2, all right? All right, so that's just I2 flowing all the way from R2, one end of R2, all the way to the other end of C2, all right? So I can actually write a potential divider equation that relates Vx, R2, C2, and VO, right? So let's do that next. So I can write the potential divider equation, I can't spell, divider equation, all right, for Vx and VO, all right, Vx and VO, all right. So the equation, obviously, using potential divider rule, you're going to get VO, all right? VO is going to be equal to Vx multiplied by, well, the top part is going to be 1 over SC2, right? That's the impedance of the capacitor, divided by 1 over SC2, right, plus R2, all right? Close that. All right, so that's my equation for Vx. Now, so you're just going to simplify it a little bit by multiplying top and bottom with SC2, right? So then what I'll get is Vx. Okay, so I'll multiply top and bottom by SC2, which means the top part is just going to be 1, right? Because SC2 will cancel out with that one. And then just the bottom part will just become, I'll just write it down. So 1 divided by is going to be 1 plus SC2, oops, 1 plus SC2 times R2. All right, that's it. So that's the equation for VO equals for VO. So since I want it in terms of Vx, so then I'll just continue here. All right, so I'll say therefore Vx is simply equals to VO multiplied by 1 plus SC2 R2. All right. So now I have an equation for Vx that I can then substitute into these Vx's here. Yeah, there's a Vx here and a Vx there. All right. So now we can substitute. So substituting, well, a whole bunch of stuff. Basically, IF, I1, I2 into these three equations. So let me do that. Substituting into the KCL. All right. So therefore, IF, well, IF is just this. So this is IF here. So I can copy that. All right. So that's going to be that. That's IF is equal to I1. Well, I1 is just this. So copy that. All right, and then plus I2. Well, I2 is simply this. All right. Okay. All right. Okay. Okay. So once I substitute into the KCL equation, then I get this. So now I substituting that equation, substituting Vx into above. So into above means this equation here. So I'm gonna get I'm gonna get VO there, right? That's fine. So I put a bracket. So VO minus oh, sorry, minus. Now Vx is going to be this guy here. That's Vx. So copy that. All right, we'll copy that. So that's going to be Vx. Oops, I think I need to be inside there. All right, Vx, close bracket. Right, and then outside of the bracket is SC underscore 1. All right, so C1 rather is equal to well, Vx minus all that. So I'm going to put replace Vx, right, with that expression that I had found earlier. All right, all of this is divided by R1. Okay, plus, sorry, plus, and the last part is just, well, I'm just going to copy it down because there's no difference basically. All right, SC2. Okay. All right, so now I need to expand this. So I'm going to copy this code. This equation down. So expanding. All right. So how do I expand? Well, if I notice here inside this bracket, there's VO. I can factorize VO. So maybe I'll just say expanding and factorizing. All right, so here's going to be VO multiplied by 1 minus, and then this thing here, right? That's inside the bracket there. And I'm not going to say anything on the right yet. All right. Okay, so okay, I think I'll put this on the next line so that I can continue from here. All right, so then we continue. All right, so here, so then this part here becomes, well, 1 minus 1, that's going to be 0. And then 1 minus 1, and then this is basically means negative 1, right? So it becomes 1 minus 1, that's 0. And then what's left is negative of SC2R2. So that's what's going to be left after you've expanded this term. So it's just going to be negative that. All right, and all that is multiplied by the external thing there, which is SC1. Oops, I think I need to put a closing bracket here. Okay, all right. Again, I'm not going to do anything on the right hand side yet. Okay, so next thing I want to do is I'm going to multiply by R1 everywhere, right? So I'm going to multiply by, basically the idea is I want to get rid of this R1 at the bottom here. So I'll multiply both sides by R1, all right? So then I'll, okay, then I'll say, all right. So then I'm going to get an expression that looks like as follows. All right, so I'm going to, all right. So on the left side here, well, so I'm going to get an R1 terms, right? But I'm also going to be, the whole thing is going to be a negative term, right? Negative, and then you have an S here, and you also have another S there, so it's going to be S squared, all right? So I'm going to rewrite the whole left side after I multiply, after I expand everything out, as well as multiplying by R1. So I'm going to get a negative VO, all right, and then negative VO, all right, and the S is going to be S squared because you have two S's here, one inside and one on the outside, and then you're going to have a C1 here. I'm just arranging it in some kind of an order, all right, and then that's it. These guys don't exist anymore. Well, they're just inside the bracket. That's all. All right. So now I have. Oops. Okay, it's going to be a problem. Hang on a sec. Let me just cut this out and then get rid of this weird imbalanced bracket. Okay, so there. That's negative VO S squared C1 C2 R2. And then, of course, R1, because remember, I'm multiplying by R1 as well, so there's going to be an R1 here. All right. So I got, yeah, okay, so next, Now on this side, what's left is going to be just the top part without R1 at the bottom, right? So I'm going to copy that and then simply replace all of this with it, all right? Okay, and then back here is no change, right? So it's just plus VOSC2. Oh, sorry, and of course R1, because I'm multiplying everywhere by R1. So I cannot forget that. All right, so all right. Okay, so next we can collect all the VOs together on one side. All right, so we're going to collect the VOs together on one side. So I'm going to put the VO on the left side. All right, so I'm going to have so the VO on the left side. So I'll keep that negative. So negative. I'll have VO on the outside, and then inside the bracket, I'm going to get a few things. I get an S squared, C underscore 1, C underscore 2, R underscore 1, R underscore 2. All right. That's this term here, right? The original term, and then you have this term here, which is 1 plus SC2 R2. So this whole thing goes to the left, so it becomes a minus. So it's going to be a minus here. Oh, sorry, it's going to be a plus because it's going to be multiplied by that negative here. So it's going to be a plus. So when you multiply a negative, you get that minus VO thing, right? So this one here is going to be 1 plus SC2 R2. All right, that's this term going to the left. And then lastly is this term going to the left. So again, this is a plus here, so it goes to the other side, becomes a minus. But then because you multiply by that minus there, it becomes a plus again. So it's going to be plus S R1 C2. All right, C2, and then close bracket is equal to, all right, negative V underscore I, right? So that's what's left on the right hand side. All right, so now what I can write obviously is in terms of V over VI, right? Since both sides are negative, so I can bring that negative VI across the other side. Therefore, what I'll have is a sorry, I need to push that to the oops. So what we're going to have here now is a VO, of course, over VI. All right. So imagine that I'm taking that VI across the other side, and this whole term goes to the right hand side. So it's going to be a 1 over this very long thing. All right. Okay, I'm going to simplify this as well. If you notice, both terms have SC2 in it, so I can factorize that. So it becomes SC2 and then R1 plus R2, right? So I think I'll do it here straight away. So that means I'm factorizing SC2 here. So then I can say in bracket is going to be just R1 plus R2. Right? So then this part is no more. So it's going to be like that. Okay? So then I can rearrange it in terms of first I put S squared, then I put S, and then finally I put that 1. So that's what I'm going to do on this side. So 1 divided by, I'm just going to that term. All right, okay, finally. Okay, so now, that's my equation so far in terms of all the components. Typically, we finish off by basically turning this into an expression where the S squared terms stand by itself, which means that to do that, obviously we need to divide both top and bottom by C1, C2, R1, R2. Then I'll just have an S squared term here, right? So let's do that. So let's just, I'm going to put to the side here. I say, so divide by C1, C2, R1, R2. All right. Okay, that means both top and bottom. All right. So then, what I'll get is I'm gonna get a VO over VS. Sorry, VO over VI. V output over VI. all right, is going to be equal to what? Well, the top part is going to be 1 divided by C1, C2, R1 and R2. All right, oops, sorry, R1, R2, all right. So that's going to be the top part. And then all of that is going to be, okay, let's see if this thing works. Okay, so all of that is going to be divided by, well, the s squared term is going to be now by itself, because if you divide by C1, C2, R1, R2, then it will cancel out with this C1, C2, R1, R2, right? So it's just going to be just s squared plus, all right, so now this is a little bit more, slightly more complicated. Basically, if I divide this by C1, C2, R1, R2, well, the C2 will disappear, right? The S will be there. But the top part will just be R1 plus R2 at the top. And the bottom will be C1, excuse me, C1, R1, and then R2. All right? And then close that. Okay, that's what it's going to be. And then finally, plus 1 over C1. Remember, we're dividing everything by this term, right? C1, C2, R1, and R2. And I close the bracket, and hopefully it becomes, there you go. So that's the final answer, all right? So that's basically h of s. So I'll just add that over here. So therefore h of s is equal to VO of s over VI of s. And this is the final expression. All right. All right. I hope you guys understand the analysis of this. In future videos, I'll do one where it is not a unity gain configuration, where actually there will be some gain, and it's typically called an equal value design. All right. So until then, see you guys later.